It's been partially taken apart. I could pretend it's because I wanted to show you what it looks like in the inside, but really it's because we had some technical problems in the other hour. But this is a good opportunity to see what's going on and how a Van de Graaff generator, or van de Graaf if you're Dutch, what is it really doing? It's really a simple machine, and these should not cost as much as what they do. Basically, first of all, they have this large round sphere. If we had a really good one, it should have a nice big round sphere. And do you notice my sphere is not really spherical, which is I'm not too happy about either. But why, first of all, would you want a big round sphere?
Leakage.
Okay, we don't want leakage, right? This is supposed to generate static electricity, so we'd like a lot of where does static? I had people drawing static in the middle of a wire on one of your worksheets. Static is a surface phenomenon. So we're talking about surface buildup of charge, and the more surface we have, the more we can build it up. We also talked about round shapes preventing leakage. I'm not really happy that this round shape was made by putting two bowls together and there's a seam, okay, which doesn't allow for a perfectly smooth. And I would expect normally you'd want it to be shiny too and completely glossy, smooth, polished. But okay. Then we just have a motor here, and we have basically think giant rubber band or belt, a rubber belt, and it's rubbing. And this unit's actually grounded so it can pull electrons from the earth, okay, or the ground. And actually, I can pull this top off. And if you were able to see, I will lean this so I don't know. Oh, please don't fall apart though. Too many things happening here. In the top, if you could see this metal thing, it has basically a comb. It has little pointy things on a piece of metal, and that's attached to this top right here. And why would this have little pointy things? Because as this belt rubs, the belt gets a charge, and where does the charge? It would just stay on the belt, but if you have little pointy things, won't that leak charge from the belt? Mm-hmm. And that leak charge is connected to this, and this is connected then. This sits on top to transmit or transfer that charge to here, okay? And that's all it is. Motor turning belt with little pickup, little sharp points attached to this. Okay? What else do we want to say? Did I answer that question? Okay. Then I have another, I'm going to turn it on in just a second. I have another little sphere, and this, I have different ways I've done it when I didn't have a plug. This one has a plug, and this plug actually ends up going to the ground. When I plug this in here, do you know that thing? That's called the ground plug. So this actually does eventually attach this to the earth or lots of wires, and this is grounded. So this thing is going to be, this has a wire, and it is literally attached to the outlet and grounded. I have had one like this before where I've just taken a wire and attached it to the faucet so that it's grounded by just attaching it to a bunch of metal. Okay? All right. So I need someone to man the lights. All right? Someone want to turn off lights for me because it's much more exciting that way. We had trouble that the belt actually fell off the little wheel that's on this other side. We are hoping that doesn't happen. Okay. Really quiet. Don't know why. Oh, but we're getting some charge. Okay. Okay, so I'm going to let that charge up a little bit and gather some charge on the surface. The other hour, there was one little spot that was just shooting off by itself, and I don't know, there was a little surface imperfection in a place that it was leaking. Okay, so we have some. Okay. Now, why is this a sphere too? This is helpful because it only is going to jump if there's a big difference between this and this. This doesn't really want to take it because it's round, but if there's enough, then it will jump, okay? See, if you hear that change in speed in the motor, I don't know what that's about, but now it's good. Do you see it's actually moving, this thing? I'm not jumping back. It is. Later, you'll get a chance to actually play with this, okay? But you can see the electric force between them. Okay. All right. So, and yes, you can do your hand as well. All right. You feel it. There's different, the worst time is usually when you're not expecting to get shocked. When you're expecting to get shocked, you're ready for a little bit. That's fine. If I lean over and I get it to my head, I get a little upset. It's always when you least suspect it that it's a problem. Okay, so we can do some tricks here. So why did I unplug it? Because I want to mess with it in a second. Does this have charge right now? Should. If I don't have too much leakage, if my air molecules are not carrying away too much charge, if this round shape is tending to hold this. So I can discharge it, right? And now it should be discharged. And I'm going to take basically just some paper with some tape and put it to the top, okay? And can you figure out what should be happening with this? All right. So I had people ask me, is this thing following me? No. Is it recording? Mason? All right. I don't think it's recording, and it's not following me.
Yeah, it's recording. It's counting.
It is recording. Okay. All right. But why wouldn't it's not swiveling?
That button's flashing. Press it again.
The red button?
Yeah.
This turned off is what happened.
Okay, so what's happening here? I had a lot of people, and I marked some people wrong, Seth. I marked some people wrong on their worksheet when they said, if there's a lightning cloud over you and your hair stands up, why is your hair standing up? And I had a lot of people tell me, oh, my hair is attracted to the cloud. Is there a cloud over this? Does it need a cloud to make it stand up? No. What it needs is just, like in this case, here we have some kind of a charge, whether you think it's positive static or negative static, and whatever, you see how I'm affecting it, whatever charge it is, every piece of paper has the same charge. So every piece of paper is repelling every sheet of paper and defying gravity, the force of gravity, to do so. Did it need a charge up here to be attracted to? No. All it needed was the repulsion of the same charge. Okay? So all these pieces of paper have the same charge, all right? I obviously don't, so it likes to follow me, okay? All right. Now, what's going to happen if I unplug this? What should happen? Theoretically, it should stay, but we see that there's obviously some leakage still. It can't keep up. So we see a little bit, some staying, but because of leakage, it's falling. It should stay if there's no moisture in the air and nowhere to leak to. Okay? That was falsely giving you a sense. But if I discharge it, which I just did, now it should all have lost its charge. Okay? All right. Oh, now I need. I like your hair. She's got a ponytail. I need you.
Okay.
And we're going to find out. See, I saw this question. It said, if you hold on to the sphere, will you get shocked? So we're going to find out. Okay. Then we need to. I'm going to put you safely on this side. I don't want you on this side because this is danger. Now, even though you don't touch the outlet, if you are getting a lot of charge and you're close to somewhere electrons can easily, readily go to the ground, you're going to get it. And I've had it a lot. Like if I turn around, I get it right in my little tush, wherever, and it's a big surprise, and it'll be a big discharge. So we're not going to keep you on that side. Now she's really scared. All right, so you're to stand on the stool. Why am I going to have her stand on the stool?
Because it's not grounded.
Because it's not grounded, or is it grounded?
It's not.
Not grounded, right? So we want, what's the opposite? What are we really doing? Insulating her. Because I don't want charge to travel through her, because that might hurt. All right, so put your hands on there. I already just said on it. Yeah, there you go. All right, now we're going to plug this in. All right, and we're going to take a look. And she's going to feel it. Oh, my. Oh, let's move this stuff away.
That's cool.
That's very interesting, isn't it? You see we're lighting the fluorescent tube that's laying right there. Okay. In fact, I'm going to actually detach this. Let's see if I don't get shocked here. Okay. All right. So you'll actually hear the motor can change a little bit. As she's taking charge, it can strain the motor, although I don't know. You feeling anything? I don't see too much going on.
The hair in my arms is standing.
Okay. So, which is again, like if you're outside and the hair on your arm stand up, you go, let me take cover. Let me go somewhere. We'll talk about where to go. Shake your head. Let's see if we get anything. Oh, we're getting a little. Do you see? All right. If she doesn't use too much conditioner, we can get it to really stand up. Okay? Do you feel it? Shake a little more. We're not getting too much. And it could be this is not working so well this hour. I'm not really sure. You should be pretty good. But I've had it. I don't know if you've seen the district website before, where Katie Tewksbury, her hair is literally a circle around her head, and it was the best I ever had happen. And now we had the other hour we had a little bit better, but shake your head a little bit more. Okay, we can see some flyaway a little bit, not super good. So is she getting shocked right now? No, because if you're going to get shocked, that you're getting transmittance, right, of charge. So when would there be a problem here? Right. So if like I touched her.
Oh yeah.
Right, there'd be a problem. Yeah. See, I do it to some people. Some people I'm not too mean to, but if I grabbed onto my faucet and then grabbed her, right, there might be a bit of a problem. Okay, but now she's just part of the system. Isn't she part of that globe? So everywhere, if this is negative, everywhere is negative on her then, right? Okay. Now how do you let go, though? No, it's not so bad to let go. All right. So, okay, you can let go. It should be okay. And she has a charge still. I can help your hip. There we go. Did you see the? It's a little bit of flames going on. Okay. So again, we didn't need a cloud over her head to necessarily make her hair stand up. Okay. It wasn't perfect though. Okay. All right. So did we answer all those things there? All right. Now we'll have some fun. I always discharge it because, again, I'll lean my head close to it and then it's like it. We're gonna have a little fun. I gotta get my props in order here. All right. This looks like I've eaten a lot of pie. All right, let me move on. All right. So what do you think should happen? What should happen here? Well, if all was perfect, it would. Okay? I can't quite make it happen. But I can do this. All right. Oh no! Whoa! This way. This way. Okay. All right. Why isn't the last one moving?
Nothing's recorded.
I taped it. So, if life was perfect and we could do this perfectly well, right? We could get them to just hover, right? Like Millikan's oil drop experiment, right? where if this was negative and this was negative, then they would repel each other, and we could make it to 5 gravity. Where the force, we know the force of gravity is pushing down, and we know at least this electric force is as much as the force of gravity, right? Because it lifted it up. If it was perfect, we could make them hover. But if there's a little bit of a tilt one way, it shoots off that way. So we can't quite get it perfect. Okay? So we know force of gravity is down. We know, right, the electric force is up, right? And what else do we want to say? I don't know if I asked for field direction. If this is negative, right, and this is, and some we can consider a Van de Graaff positive and stuff, but we're just going to say it's negative. If this is, it's a little more complicated, but we'll just say negative and negative, and so we know this is then force for repelled up. Okay? All right, at least equal to the force of gravity. All right. I ate a lot of pie. Okay. Fluorescent tube, so we just saw that going off here. I'm going to turn this on again. And we will have time for everyone to play with this stuff at the end, hopefully. So, maybe we'll plug that in. Was this plugged in when we were having that fun?
Yes.
I hate touching electrical things when there's no cover, when... what's bad? Getting it to your head. I don't get a charge in my head. All right, so we had kind of mixed results the other hour with this. Oh, that's not bad. All right, so just like we were able to light the fluorescent tube with our static PVC pipe, we can do it again here. We can see that it's traveling to me. Theoretically, it should work better. Do you even want to do this? You know what? No, it's leaking more. So I'm not getting the big shot. I'm not feeling it. Oh, it's always nice when I don't feel it. Okay, so we can definitely see the pathway. It would like to run, through the tube to me. Okay, if you go like this, right, this won't light up because it doesn't want to go through the tube this way, right? Especially if there's an equal charge from this end to this end, there's no reason, or the electric field is the same, there's no reason to want it to go this way. All right, so we did not too bad. All right, it helps if I hold on to the metal end. All right, and it turns, ow! Okay, see, when you don't know it's coming, that's when it's bad. All right, it works really well. I'm not sure why now. I should stop while it works, okay? All right. Okay. The Mylar. So here we have Hello Kitty and another Hello Kitty. All right. Both gifts. All right. And Mylar is basically just metal coated plastic. So this is another surface that can have a bunch of charges on it. One tends to work a little better than the other, but what charge does this have right now? Neutral, right? Okay, that's, let's say, negative. And what's the first thing that's going to happen here? Beth, what'd you see? Did it first attract? Why did it attract? If this is a neutral object and this is negative, don't the electrons flee to the other side and it polarizes, so one side is negative, one side is positive, right? And then it attracts. But did you see what happened right after that? Two things happened. First it attracted, right? It touched. What happens when it touches? That's conduction. A bunch of electrons jumped on here. Then this charge is the same as this charge, right? And then it repelled. Did you watch what happened? Let's keep doing this and let's keep torturing your teacher.
Oh, it wants to touch you.
So what's happening now? Why is it going back? Because it repelled, found me, discharge on me, was neutral again, got induced, hit the Van de Graaff, conduction, transfer charge, flew away, hit me, I get shocked just repeatedly. I do this all day long. Okay? I'm kind of glad for my sweater because it kind of dissipates the charge a little bit. All right? But it will just continually do that. Okay. What else do we have? Oh, we're going to stop for a minute. We're going to come back to Faraday cage because the school stole my Faraday cage. Maybe because it looked like an animal cage hanging from my ceiling. I'm not sure. But we'll watch a little YouTube on the Faraday cage. The nail. This sounds scary. Yeah. I don't bring my head too close to the nail. All right, so I got a big nail. I'm going to have it in my hand. I'm going to bring it close to this. What do you expect should happen? What's going to happen to Miss Jones?
There's a line of electricity shoot out.
Okay, will it shoot out? Let's see.
Ooh.
Got nothing. But it's a pointy object, Miss Jones. And pointy objects should be like a lightning rod, Miss Jones. Shouldn't I be like? Yeah, maybe. But what's our first thing we say lightning rods do? Do they cause a lightning bolt? You know what they do? They leak. So I'm getting a bunch of little leaks out of this and not a big jump. My swivel's not following me again. I'm wondering if, I don't know. It's upsetting. Look, I have to turn the swivel. Isn't that a problem? Okay. So this is leaking charge. It's not going to do what this does. If you want to see a big bolt, really, this is what you do. You have a round sphere. Because a round sphere will allow charge to build up so it's big enough, and then it zaps. Okay? All right? This is going to leak charge off. Now, of course, I'm also not grabbing onto an outlet right now. Okay? But I'm not going to get the big giant zap. Okay. We love a cup of confetti, isn't it? All right, it's not really confetti. This is the hole punch. What do you think's going to happen now? All you have to do is look around here. My lab assistants are going to take care of me. Yay, party, physics party. All right, so what's going on here? Same thing. So the paper is obviously getting a negative charge